there, and welcome to this next video in the Integrated Math 1 video series. Today we're going to talk about something called standard form of a linear equation. Before we get into that, let's go ahead and do our 4 problems for our warm-up for today. If you'll take a second and try to do those. Alright, so in the first one here, f of x equals 2x minus 4 and g of x equals negative 3x plus 1. We're looking to find f of 3 minus g of negative 2. And so we've talked about function notation earlier this year. And so really we're going to do those separately and then subtract them. So f of 3. So all of this equals f of 3. So that means we're going to put 3 into f. So this is our function that we're calling f, and we're putting 3 into that function. That's what this notation right here means. Then we're going to put negative 2 into g, which is this function over here. So we've defined it as g, and so we're going to put negative 2 in there. And then, of course, we're going to subtract their results. All right, so let's see. 3, if we put 3 into f of x, we're going to get 2 times 3 minus 4. And then, of course, minus g of 2. So g of 2 is going to be negative 3 times negative 2 plus 1. So let's see, negative 2 times negative 3 is positive 6, plus 1 is 7. So we're going to end up subtracting 7 there. So minus 7. From, let's see, 6 minus 4 is 2. So 2 minus 7 equals negative 5. So f of 3 minus g of negative 2 equals negative 5. All right, number 2. What is 1.04% of 60? That's an increase of 4% of 60. So we should get something just above 60. So let's go ahead and multiply the two numbers involved without trailing zeros. So that's going to be 1.04. So 104 times 6. 104 times 6. So 100 times 6 would be 600. 4 times 6 would be 24. So that'll be 624. 624. But that's way too much because again we're just increasing by 4%. So we need to move that decimal and get 62.4, which makes a whole lot more sense there. So 62.4. Number 3, given y equals negative 4x minus 12, find the x and y intercepts. As we talked about before, this is something called slope-intercept form. So because it tells us the slope and it tells us the y-intercept. So we know the y-intercept just by looking at the at this form here. So the y-intercept is the point 0, negative 12. The x-intercept is a little bit harder to find here, but we can do it. It's the x value that produces a y value of 0. So while this one is the y value when x is 0, the x-intercept is the x value when y is 0. So we're going to have something comma 0 for our x-intercept. So you see how that switches places there. This is our y-intercept. This will be our x. Okay, so let's figure out what is the x value when y is 0. So let's just substitute 0 in for y, and let's figure out what x value makes that happen. Okay, so you could solve this. We've talked about solving equations, or you could just use inspection and try to figure this out. So we need this to be positive 12, right? So that 12 minus 12 is 0. So negative 4 times what gives us positive 12, and that's going to be negative 3. So negative 3 is going to be our y-intercept. Again, you could solve it. Let's see, 0 equals negative 4x minus 12. You could add the 12 on both sides here and get 12 equals negative 4x. And then when you divide by negative 4, you're going to get negative 3 over here equals x. So again, there's a different way of solving it there. But either way, you get negative 3. So our x-intercept is negative 3 comma 0. Lastly, given this, we've talked about maybe not naming this form, but this is what we're going to get into today. But we've seen things like that, where it's written in this way. and how to work with that. So solve for y here. So if we solve for y, again, going back to our last video, we talked about rearranging literal equations, solving for certain variables. Same thing here. So when we solve for y, I'm just going to rewrite it down here. Let's see, 21x minus 7y equals 35. Okay, so to solve for y, we need to do the inverse operations in the reverse order. So normally we'd multiply first and then add or subtract, but now we're in reverse order, so we're actually going to do the adding and subtracting first. And so we're going to subtract 21x from both sides. 21x minus 21x is 0, so we're just going to look at negative 7y equals, and then we cannot combine these because they're not like terms. 1 is multiplied by x and 35 is not. So we're just going to leave it as negative 21x plus 35. From there, we can divide both sides by negative 7. And we're dividing the whole left side and the whole right side. Okay. The only thing is with division, we can actually end up dividing each one individually. And so we can divide both terms by negative 7. So we get y equals negative 21x divided by negative 7. Let's see, negative 21 divided by negative 7 is positive 3x. And then positive 35 divided by negative 7 is negative 5. All right, so that is the slope-intercept form. We said solve for y, but really what we were doing is we were converting from this form here, which we're going to talk about today, into slope-intercept form. So the slope of this is 3, and the y-intercept is negative 5. All right, so again, our goal for today is to graph linear equations in standard form, but also be able to rewrite equations in standard form in slope-intercept form. And if we go back to our bell work here, our warm-up, this is what we call standard form. So I'll go ahead and throw that term around here. This is what we call standard form, and then this is slope-intercept form. And we're going to be working with the two today, but mainly thinking about how to graph these and create them given a real-world context. So let's look at our first example here. We've seen one like this, similar to this before in a previous video. It says a company used 2 different size trucks to deliver sand. The first truck can transport X cubic yards and the second Y cubic yards. So the first one is X and the second one we'll do in blue is Y. The first truck makes 5 trips. I'll go ahead and do that in red because that corresponds with the X cubic yards, both describing the first truck. And then the second one makes 7 trips, so we'll do that in blue. The total amount of sand delivered was 70 cubic yards. So altogether, if we add the total that the first truck took and the total that the second truck took, altogether that makes the total amount of sand that was delivered. So it says write and graph an equation to represent this situation. Again, we've done something like this before in terms of writing it. All right, this is going to be, let's see, if the first truck makes X cubic or 5 trips, each one carrying X cubic yards, that's going to be 5X, and let me put that in the red, 5X. So 5 trips with X cubic yards each, that makes a total of 5 times X cubic yards for that first truck. And then for the second truck, it makes 7 trips with Y cubic yards each, that'd be 7X. Then of course we're going to add them together. When we add them together, we get the total sand that was delivered, which is, it should be equal to 70, because that's what it says here. All right, so now we got this equation. And if you remember, this is what we call something in standard form. This is a linear equation in standard form. So what we want to do is we've written it, now we want to graph it and see what we can do there. All right, so we don't see anything in particular here. We don't see the slope, we don't see the y-intercept. So maybe it's not as easy to do right away, given those same characteristics. But we can do something else fairly easily, and that is find the y-intercept and the x-intercept. Remember from our warm-up, the y-intercept is when the y value when the x value is 0, and the x-intercept is the x value when y is 0. So let's think this through. Let's start with the y-intercept. What is the y value when x is 0? All right, well, let's see. When x is 0, so if we put 0 in for x here, well, 5 times 0 is just 0, right? So when we put 0 in for x, that's going to leave us with 7y equals 70. So y equals, divide both sides by 7, and you get 10. So 10 is the y-intercept, so the point 0, 10 is going to be our y-intercept. All right, so that's how you find the y-intercept. How do we find the x-intercept? That's the x value when y is 0. So we're going to do the same thing, but now we're putting 0 in for the y value instead of the x. So put 0 in for y, and we get, let's see, 7 times 0 is 0 again, right? So really all it's going to leave us with is 5x equals 70. All right, so divide both sides by 5, and we're going to get x is equal to 14. So that means our x-intercept is the point 14, 0. All right, so really what happened here is we put in 0 for the x, solve for y, then put 0 in for y, and solve for x. It's kind of the same process both ways here. What some people like to do is what's called the cover-up method. When we put 0 in for either one of these, that whole term goes away, right? So what you could do is to find the x-intercept, you just cover up the whole y part. Now you're left with, if we cover that part up, we've got 5x equals 70, right? And you can solve by dividing by 5, we get 14. To get the y-intercept, you cover up the x part, and you have 7y equals 70, so y is 10. So it's because we're putting in 0 for those terms that we can kind of cover them up. So I definitely want you to understand why we can do that, but that is a method that you can use to find the x and y intercept. And then once we plot those, a line is defined by 2 points, right? So we can just take our ruler out. Once we plot the x-intercept and y-intercept, make our ruler go through those points and then draw the line that connects them. And there we go, there's our graph, right? So if we look at the graph here, okay, so you can see my equation up here, 5x plus 7y equals 70. I've defined my x and y intercepts, or x and y axes. The y-axis is the number of cubic yards that the second truck took per trip, and the x-axis here is the first truck cubic yards per trip. All right, because that's what x and y were defined as, right? X cubic yards and y cubic yards per trip. So if you look at the graph here, we have our y-intercept. There's our y-intercept, 0, 10, and our x-intercept, 14, 0. And you can just take your ruler out and connect the 2 points to create your line. All right, so that's how these are related. Overall, they took 70 cubic yards. If let's look at the y-intercept here. If the first truck took 0 cubic yards each trip, so basically they didn't carry any sand, that means that the second truck took 10 per trip. It had 7 trips, so that would be the total of 70. If the second truck took none each time, that would mean that the first truck took 14 each trip. But you've got some in between, right? You've got, let's see, all kinds of different values in here. Let's say here, at this point here. So that means that the x value is 7.64, so that means the first truck could have taken 7.64 cubic yards per trip if the second truck took 4.543 cubic yards per trip. So it relates the two values in a nice way. And so these are all the possible values that the trucks could have taken per trip. All right, that's kind of what we're looking at here. All right, let's look at the next one. Before we do that, again, these are the two forms. We have slope-intercept form, slope and y-intercept, and then standard form, which has three values involved: the coefficient of x, the coefficient of y, and then our constant on the other side. And so you can kind of see the general forms of those. All right, let's see. If the perimeter of a rectangle, rectangular garden is 6 feet, write an graph, an equation that relates the amount of fence used for the width and length. All right, so we have 6 feet. Remember, perimeter, we talked about this last video. Perimeter is 2 times the length plus 2 times the width. That's going to add up all the sides of our rectangular garden. All right, so let's write an equation. What's the amount of fence used for the width and length? So we know the perimeter is 6, so we can go ahead and fill that in. P is 6, and now we've got an equation. It may not look like the same form. Maybe we can reverse the order here, 2L plus 2W, and you can even use X's and Y's if you want to. I like to use L's and W's, but when you go to type it in on something like the calculator or on Desmos, notice here it says 2x plus 2y equals 6. All right, so let's see if we can figure out what's going on with these. Okay, so what is our y-intercept? 6 divided by 2 is 3, right? All right, what is our x-intercept? Again, 6 divided by 2 is 3. So they're both 3. And as you see in the graph here, they are, right? 0, 3, 3, 0. Draw the line down, and this relates the width to the length. All right, and you've got all these values in between. So the width could be 1.34, and the height or the length could be 1.66, and that would create a perimeter of 6 still. So any of these combinations of width and length would create a perimeter of 6. So we have all the different possibilities here that would satisfy that condition of having a perimeter of 6. What if one of the sides, we'll say the width, just to simplify it a little bit, what if one of the sides of the garden was the house? So the garden backs up to the house. So really all we need is fencing for one of the widths. So if we draw like a picture here, so this will be a length, this will be a length, this will be a width, and then we have, we have the house here on this side. So we don't need fencing for that side, but we still have a fencing amount of fence that's 6. We'll say it's still 6. So how that change things? Well, so now L plus W should still be 6. So we have 2L plus W equals 6. All right, so that means, let's see, L up here, just make sure here. Yeah, X plus 2y. So in this case, I represented the width with X and the length with Y. So we have 2y plus X equals 6. Or you could reverse these if you wanted to, X plus 2y, it doesn't really matter. But I typed it in like this on Desmos. So okay, let's figure out what's the y-intercept and x-intercept. The y-intercept is still 3. What's the x-intercept though? Just 6, right? Yeah, just 6. So if you see the graph here, the x-intercept is 6, the y-intercept is 3, and so we can see the relationship with that there. So again, any of these points here still satisfies a perimeter of 6, now taking into consideration that we don't have one of the sides. And so kind of a different situation there for you to think about. All right, let's move on to our next example. A company buys X ink cartridges for $15 each and sells Y ink cartridges for $23 each. The company profits $3,542. So the question is, same thing. Let's write an equation and see if we can graph it. So if we sell X ink cartridges for $15 each and Y for $23, the total profit is $3,542. So take a second, see if you can write an equation that represents this situation. All right, so if we buy X ink cartridges, so we're losing money when we buy cartridges, right? We're giving away our money to trade for cartridges. So we lose $15 per cartridge that we sell or that we buy, and then we add $23 for every one that we sell. All right, we're profiting $23 for each one, and it equals $3,542. So how can we find the X and Y intercepts? Well, we could divide. 3,542 divided by negative 15, 3,542 divided by negative 15 is negative 236.3, with a 3 repeating. And so then the Y-intercept would be that same value divided by 23 is 154. So the Y-intercept is 0,154. And like I said a minute ago, the X-intercept is negative 236 approximately. It's like 0.13 repeating, comma, 0. All right, so we have a negative X-intercept, positive Y-intercept. Let's see what the graph of this looks like, because we could plot both of those and connect them, right? All right, here we go. So if we plot the X-intercept here, that's negative 260 something, and then positive 154 right here. Yep, 154. And then we can connect those dots and the points, and then we've got our linear function. So from there, we can actually figure out some things. So our x-axis are the number that we purchased, and the y-axis represents the number that we sold. So we can't go negative on either axis, right? Because we can't purchase a negative number of ink cartridges. So really the only thing that makes sense in this context is the first quadrant here. So if we start with the y-axis here, if we didn't buy any, but we sold 154, we would still profit that 3,542. All right, but there are a large number of other possibilities. So if I scan through here, all right, hit this one. I could purchase 69 ink cartridges and then sell 199 of them, and I would still profit 3,542. So this line represents all of the different possibilities of ink cartridges that I could both purchase and sell, combinations of those that would still result in that same profit. All right, this is kind of our last example here, which is going to be a two-part one. The first part here, Heather has nickels and dimes in her purse. She has a total of 25 coins. Write and graph an equation that relates the number of nickels and the number of dimes. So we got 25 coins, we got nickels and dimes. So we could just start plotting things out here. So if we had 0 nickels, how many dimes would we have? We'd have 25, right? What if we had 1 nickel? Then we'd have 24 dimes, right? Because we know that the total number of coins is 25. So we could just list all of these out, right? 2 would be 23 dimes, 3 would be 22, on down, right? Even if we had 12, we could quickly find that the number of dimes would be 13, right? As long as they add up to 25. So in general, we have N plus D must equal 25, where N is the number of nickels, D is the number of dimes, and the total of those added together should be 25. So N plus D equals 25. Let's look at the graph of this. So I've used X and Y instead of N and D, but it works out the same. So the X-intercept would be 25 and the Y-intercept would be 25. Right? If you have 0 of one type of coin, you have 25 of the other, right? So both of these should be 25 in terms of the intercepts here. All right, but you could have a number of other possibilities. Let's see if I can, there's the 12 and 13, right? 12 nickels and 13 dimes. So these are all the possibilities. Obviously we can't have a decimal number of these. So really the only thing that would make sense here is the integer values. So like, I had it a second ago, let's see. 22 and 3, like that one right there. That would make sense, right? 22 nickels and 3 dimes. So this graph here relates the number of nickels with the number of dimes given that there's 25 of them. So it's all the different combinations here graphically represented. All right, in that same scenario, we've got Heather again. Heather has nickels and dimes in her purse. We don't know how many, right? She has a total of $13. Write and graph an equation that relates the number of nickels and the number of dimes. So same overall context, but different scenario here. So we know that the total amount that she has is $13. So let's see. We don't know how many nickels, but let's say she has N nickels. How much is a nickel worth? It's 5 cents, right? In terms of a whole dollar, how much is it worth? It'd be $0.05. All right, 0.05. All right, what dimes? Dimes are worth 0.1 or 1/10 of a dollar, right? 10 cents. So if we take the number of nickels, multiply by 0.05, take the number of dimes, multiply by 0.1, and add them together, that gives us the total value of her coins, which should equal $13, or must equal $13. Okay, so if we graph this, let's see. Let's try to graph it by hand first. If we were to cover up the nickels and solve for the dimes here, what would that intercept be? So 13 divided by 0.1 is 130. So 130, and let me just make sure here, did I make dimes? I made dimes my y-axis here. So that would be the y-intercept. Okay? And then if I solve for the number of nickels, if there were 0 dimes, let's see, 13 divided by 0.05, 260. So this would be 260, 0. So that's my x and y intercepts, and I can graph it from there. Just connecting those 2 points to create my line. And here's what the graph would look like. All right, got my number of nickels down here, the x-axis. Again, 260 is the x-intercept, 130 is the y-intercept, and then again, I still can only have integer number of nickels and dimes, right? I can't have a fraction of a dime or a nickel. So, but these are all the possibilities here. Let's see if I can find one here. 68 and 96. So I could have 68 nickels and 96 dimes, and that would create $13. So these are all the different combinations of nickels and dimes that would create $13. Again, if I had 0 dimes, I'd have 260 nickels. If I had 0 nickels, I'd have 130 dimes. And so that just graphs the relationship between nickels and dimes with the constraint that they have to add up to be a total of $13. Okay, so we're gonna look at that scenario a little bit more in our next video and see if we can figure out some other things about that scenario. But hopefully we gained our goal for today, which was to graph linear equations in standard form, again by finding the x and y intercepts and then connecting those 2 points, and then rewrite equations in standard form and slope-intercept form as we did in the warm-up activity that we did earlier. Let's go ahead and go back to that though and make sure we understand how to do that. So let's take this one for example. If we were to solve for y here, let's just do this in red, we'd first add 15x to both sides. So that would give us, I'm gonna write it over here, 23y equals 15x plus 3,542. And then I'm gonna divide by 23 on both sides. So we get y equals 15 divided by 23x plus 154. That's what that ends up being, 154. So that's how we convert, just to remind you once more, and then how that connects to the graph. So if we look back at the graph of this one, it should have a y-intercept of 154 and a slope of 15 over 23. Yeah, so go up 15 over 23, up 15 over 23. There's our slope. Y-intercept is 154. So just wanted to reiterate that before we finish up here today. All right, so in our next video, we're going to continue to look at the situation with Heather and her coins in her purse to see if we can continue to think about how to solve things involving linear equations. So hopefully you'll join us then.